And hopefully I can keep you awake after lunch. If you're going to snore, just do it quietly, please. All right, so we're going to talk about this idea that AI, all infrastructure in the future is going to be AI infrastructure. But the first question I have to answer is, why is Mirantis having this conversation? And why do we feel that we're in a position to telling you how this should be set up for the future? Our background is in running large-scale infrastructure for a significant number of very large enterprises across the globe. The extension of that is that we have taken that knowledge and distilled that into what we're doing to run AI infrastructure, which is just an infinite layer more of complexity. So, applications are dead. Long live applications. We've all heard this. Satya Nadella spoke about this. As we start to think about this idea, business logic is being replaced with AI logic. Digital transformation, and we've all been doing digital transformation projects for the better part of the last 20 years. I mean, I've been in this industry for 30, and I've been hearing about digital transformation for the last 30 years. The reality is this is truly the cusp of real digital transformation, where AI and machines are going to start making those decisions that we currently code directly on our behalf. What that means is we have an infrastructure challenge that we have to solve for at scale. Application patterns are evolving. We've gone through multiple generations of application patterns. I'm not going to go through the full eye chart here, but I think the key thing to note, when we talk about AI applications, we are no longer abstracting our workloads from the infrastructure. We are now moving to a world where we have very complex applications that are tied right throughout the stack to the capabilities of the infrastructure. We also have a lot of mixed workloads. The older workloads are not going away. The way that AI is going to interact with the real world is also not going to go away. And we have a resource constraint problem that we have to deal with. When we talk about AI apps, we tend to talk about it from the point of view of being GPU bound. GPUs are only one part of the equation. Once models get larger, once these workloads get more distributed, we need to start thinking about that whole stack. We need to start thinking about CPU. GPUs don't run without CPUs to assist the workloads, to do the data pipeline, to do the data processing. And many of the jobs run better on CPU than they do GPU as part of the whole data pipeline. We also have to think about the network fabrics. And in a talk earlier, we spoke, there are 4 network fabrics we have to take into account when building out large-scale infrastructures. We have data network fabrics, we have wide area network fabrics, we have PCI, and we've got RDMA network fabrics. All of these have to be taken into account right down to the storage layer when I'm building out infrastructure. Delivering these platforms is a challenge. The reality is we need to future-proof our platforms. We have to deal with resource scarcity. How many of you here have been involved in purchasing GPUs? Okay, so the challenge of purchasing GPUs is you have long wait cycles. And sometimes you think those things are going to arrive, and 6 weeks, 8 weeks, 20 weeks later, you still don't have your GPUs. And then the next problem arrives. They're arrived, you've got to rack and stack them, you've got to power them. This resource scarcity problem is not just about the GPUs, but about power, about data center space. We have one partner who is using 20% of a data center physically and 100% of the power in that data center. That's not great use of the resources. Sovereignty. Everybody talks about sovereignty, but what is sovereignty when it comes to AI? It is a number of things. It can be location. It can be a legal challenge. Can a foreign government legally require the company that's holding your data to give them access to it? That's a big part of sovereignty. When that company is held by a foreign holding partner, they're subject to that country's rules. Multi-tenancy, especially in this new world where we're talking neocloud, when we're talking cloud service providers, is a hard requirement. But in Europe, especially in the banking industry, inside enterprises, they have rules that require hard multi-tenancy. We have to cater for all of this. And all of this is slowing down the ultimate delivery. Throw in that we need to process our workloads closer to the customers. If I'm in Germany, and I happen to live in Germany, I have to want my data to be processed in Germany, not the US. Now, how do I do that as a multinational company? How do I ensure that that sprawl doesn't increase my challenge and my management costs? How many of you agree with this statement? Okay. So I would argue it's not that they don't care about the infrastructure, so they don't want to care about infrastructure. The complexity that they're dealing with is so great just at the application layer, but they are highly dependent on the infrastructure. Look at the great companies that are attending this event who have infrastructure, and their offerings are infrastructure-based. When I'm a developer who's learned to code, I don't want to know about and deal with the complexity of that whole stack of PCI, NUMA nodes, CPU, GPU nodes, and everything else that goes in between it. On top of all of this, and I know I'm listing a bunch of problems, on top of all of this, we have a rapidly growing landscape. There are thousands of AI platforms, thousands of tools, and growing daily. This chart is a year and a bit old, just over a year and a bit old. The latest version of this is just one black blob if I try and put it on a slide. It's unreadable. It's pretty unreadable as it is. All right, so how do we solve for this? How do we start to think about taking this forward for the future? What are the requirements? First off, platforms have to be manageable. I mean, it sounds obvious, but it's often something that's thought about after the fact in many organizations. We create platforms, we build them by hand, and we're stuck. We have to be able to update, upgrade. We have to think about the life cycle of platforms. Platforms need to be improvable. One of the key and really key things we have to do in this industry is become more efficient. We've gone through a cycle of losing efficiency within technology. We have to get more efficient. The planet cannot afford for us not to get more efficient. If you think about the power constraints that we're dealing with. We have to have platforms that are observable at every layer of the stack. Everything has to be able to be instrumented right the way up to the user experience at the top of the stack. Controllable means not just where I have control, but controllable within the public cloud providers, within my vendors, being able to control what I put down everywhere, not just within the constraints and the boundaries of my own environment. And we're talking about AI. It's all about performance. If I can't measure and control the performance of the platform, I don't really have a platform. So what does this look like? What are the key building blocks when we start to think about AI infrastructure? Starting at the top is the most important component, the application. Everything else has to lead from the workload. And we as tech people tend to think and talk and focus on the cool technical bits at the bottom. Without workloads, we don't have an industry. We don't have a reason for putting down infrastructure. The next layer down is how do we create a great experience for the people running those workloads, for the people creating those workloads? That's the app platform services. And this is the critical area where one of the largest gaps in our industry is today in the AI space. Lots being done in the developer space there, in traditional apps. The AI space, we have a gap there because we're still learning. Next layer down is GPU platform as a service. Whether I'm buying GPU platforms from one of the many neoclouds that are around, or I'm trying to run it on-prem within my enterprise, I need a simplified service that allows me to create that stack on demand. What do I need there? I need inference. I need to be able to run my models consistently with performance without fiddling with them too much. I need training capabilities. We all think of training as thousands of GPUs tied together, but fine-tuning is also a form of training. And sometimes all I need for that is a handful of GPUs just to recreate the weights on top of a platform. GPU sharing, not a big deal today. fractional GPUs. But as we move into the future and we start having, and I believe strongly we're going to start having smaller models doing very unique parts of a AI workload stack, because that's how we bring the costs down, we're going to have these monstrous GPUs. We need to be able to split them up across these workloads, especially as the older GPUs end of life within the environments. Finally, well, not so finally, we've got the last layer of the stack, which is the infrastructure as a service. And by the way, this is where 90% of the industry today is playing. It's in the infrastructure and the service space. This is virtualization, it's Kubernetes, it's multi-cloud services. But as we look at this stack, that last layer is the provider and hardware stack. And that provider and hardware stack is either running on-prem inside, owned by somebody else, inside your enterprise, or you're buying it from a cloud service provider. You have to be able to cater for all of that. But what's critical for me as I think about this is this management and observability layer that allows me to provision every layer of this stack and give us the capability to choose our own destiny. And we're going to cut into that a little bit more as part of the... So what are the questions that I need to answer when I consider the infrastructure that I'm building? First off, my infrastructure providers. Infrastructure providers are key parts of us being able to deliver any of this. Providers here can mean a cloud services provider, a hyperscaler, NVIDIA TIN, purchased through an NVIDIA partner, or a myriad of other systems that will be running these workloads. Providers can be on-prem, they can be in the cloud, they can be at the edge. You need to start to ask questions about what you're trying to achieve so you can make good decisions. Management is key, once again, to the approach you're going to take here. One of the key questions right at the top there is, are the management tools separate from the data plane? Can I choose what goes what provider? Can I manage each of those providers? And if something goes wrong with my management plane, does it affect my workload? Can I create repeatability across these platforms? Do I have to recreate things from scratch every time? What is my management overhead? I'm assuming everyone can read, so I'm not going to go through the full list. And then finally, related to management is flexibility. Can I create flexibility across my platform where I can deliver components of the platform as and when I need them and change the stack as that crazy list of different vendor solutions matures? Can I start to change out layers of the stack in a controllable way? That's what's key when it comes to what? Flexibility and manageability within the stack. So what is the goal? Ultimately, the goal as we look at it is strategic open infrastructure. To do that, we need to balance a few things within our environments. We need rapid time to value. This is probably one of the most critical things every organization needs to think about. How do I take that investment, that $100 million, $200 million investment, and get it working for me rapidly? On the flip side of that, I think about autonomy and control. You could probably do that quite quickly and lock yourself into a stack that is very dictatorial to your approach, where you have to take every layer from a single vendor, but now you're stuck. You have to wait for that vendor to innovate before you can move forward, before you can make change. We're focusing on bringing together strategic vendor solutions, somebody like an NVIDIA, somebody like many of the great storage players here. There's DD and there's Weka, there's many others who are here who are focused on great storage solutions, different networking solutions. Mixing that and overlaying a pure play open source approach to support that, and bringing in a management and control layer so that we can create the strategic open infrastructure for the world. This way is how I believe the future is going to move forward for infrastructure management to make it effective. There are a couple of key architectural capabilities that we feel very strongly are required for us to achieve this as we move forward. First off, composable infrastructure is an absolute must. If my infrastructure is hard-coded, if my infrastructure is unable to be adjusted to meet my needs, I'm stuck. Which means I become a legacy system overnight. Performance guarantees need to be part of the solution, and I'm going to touch more on that in a moment. Templates are the way we create repeatability within our stack and help us control the world around us so that we can move faster. Because a lot of these patterns are repeatable. Why recreate patterns that others have already created when you can take advantage of the patterns that are already there? Borderless computing is a critical element. Borderless computing is a critical element. This is the ability for me to find resources wherever I need them in a safe and secure way. And observability at all layers is a capability. I said more about applications. One of the things that we believe strongly as part of the vision for the future is this idea that we have to move away from abstraction of resources to contracts for resources, and creating resource guarantees at an application layer so that an application can request a certain set of performance requirements from the infrastructure, and that infrastructure will then serve that in a contract format. More on that is going to come in the future from us. Very, very briefly, I think I've got 1 minute left. Quick punt, thank you all. The platform that we're building to achieve these goals is called Cordant. Cordant is an open source platform. It's designed to support multi-cloud, multi-cluster, bare metal from the ground up, leveraging a pattern-based solution to provide a declarative approach to AI infrastructure so that we can start to move into this idea of contracts for applications into the future. I'll skip out and go, if you'd like to learn more about how we're doing this, if you'd like to learn more about the challenges that I've rushed through in the last 18, 19 minutes, please go and have a look at our AI Factory reference. It covers a lot of this in more detail. It's updated at a regular basis. We'd love your feedback. We'd love to hear more from you. Thank you.